So our first three rules that we're learning begin with this one. And so what you saw today was, if you wrote this out, we have these two right here, and this exponent is just telling us that we have two of them being multiplied, right? Okay, then we have this multiplication, and then we have these three being multiplied. And if we look at it, it's just multiplication of things that are being multiplied. And so we just have a whole bunch of multiplication. And the exponents themselves are just telling us how many they have. So we have 2 and 3, that's just going to be x to the 5th. But because there's 2 and there's 3, and we're just looking at multiplication here, it's really important that this is multiplication. We can shortcut that to just say, well, if I can figure out what 2 plus 3 is, then I know how many I have and what I have. Now I want to make a distinction, because one of the things that people do or mess up on is if we have numbers here. So let's say I had 2 squared times 2 to the 3rd. So if I had that, I'm saying that I have 2 2's being multiplied. Then I have 3 2's being multiplied. Okay, and so now if I want to rewrite that using exponents, I'm multiplying 5 2's, so I have 2 to the 5th. But one of the mistakes that people make is they say, okay, I'll add these up, I'll get a 5, and then this says that I need to multiply my 2's, so I get 4. But do you see 4 or 5 4's down there? Like, I don't see 5 4's, I see 5 2's. So we have to be careful that if we're using the exponent rules and we're saying, okay, I'm going to add these together, what we're doing is we're adding together how many 2's we have. So in the end, that base of 2 still needs to be a 2, and then I can write what it is when I add the exponents together. And people get confused about that, because they're like, yeah, but when I take 2 times 2, I get 4. And that's true because you're not using exponent rules, you're just going ahead and multiplying. What you have to remember is this is 2 to the 1 and 2 to the 1. So if I was using exponent rules, it'd be 2 to the 2, and 2 squared is 4. But I'm not going to be 4 to the second power, I'm going to be 2 to the second power. So we have to be very careful about that. What we're asking ourselves, what we're doing here is we're looking at what bases are we using, and those bases don't change unless we're actually doing the multiplication, which we're not when we are doing exponent rules. All right, so that was our first exponent rule, that we add the exponents. Our next exponent rule is, what if I have something to an exponent and then that's raised to another exponent? Well, let's use our exponents to figure this out. This 3 means that I have 3 of these. So I have x squared times x squared times x squared. So I have 3 of them. So we have 3 of those, and they're being multiplied. And if I use my last rules that we had, was that we have 2 plus 2 plus 2, so, right, 2 plus 2 plus 2. But think about that. What is multiplication? Multiplication is repeated addition. I have 3 groups of 2. I have 3 groups of 2. And so really that is 2 times 3, or 3 times 2, if we were going to go in special order. But 2 times 3, and that would give me x to the 6th, which is exactly what's going on here. I have 2 x's here, 2 x's here, 2 x's here. I have 2, 4, 6 x's, right? So I have 3 groups of 2 x's. That's going to be 6 x's. So our shortcut here is that if you have an exponent raised to another, all right, I keep getting interrupted. I have no idea where I'm at. But we're looking at exponent rules. We're looking at an exponent raised to another exponent. So if I have something like this, I don't want to write that out, right? I want a shortcut. And so what we're doing is we're saying, well, I have an exponent raised to another exponent, so I'm going to go ahead and just multiply them. Okay, and then my last that we're covering here is division. What if we're dividing them? So we've already done multiplying. What about dividing? So with this, I have 5 x's being multiplied on the top. I have 3 x's being multiplied on the bottom. And then, we're just using fraction rules that if we have something on top and something on bottom, we can cancel them. So I cancel 1, 2, 3 of them. And I'm left with 2 of them. And if we look at this, here's our fraction bar. The 2 that are left are on the top of it. So this is going to be x squared. So what happened was this 5 told me that I had 5 of them here. This 3 told me I had 3 of them here. But because these are the same base, there's going to be canceling happening. And how many cancelings is based on my smallest number. So I have 3 on the bottom that are going to cancel with 3 on the top. Canceling means take away. We're taking away the x's. There's not going to be those x's anymore. And so we're taking away 3 x's from the 5 x's we had on top. Take away means subtract. So we have 5 minus 3. Okay, so that subtraction happened on the top because that's where the most x's were. We had 5 x's on top, so that's where we're going to take away from x's. So what if my bigger exponent was on the bottom? Well, let's look at what would happen. I have 3 x's on top. I have 5 x's on bottom. Okay, now again, canceling x's, 1, 2, 3. I canceled out 3 x's. Okay, so really there were 5 on the bottom. We took away 3 of them. Now let's look at where are those 2 x's left. Those 2 x's are underneath this line, which means in my answer, those 2 x's still need to be underneath the line. And since there's nothing left on top, I'm going to put a 1 there. So when you have the most x's on the bottom, that's where the subtraction is going to happen. You're going to be taking away from those x's so that you just have those 2 left. So we take away the 3 x's from the top. And those x's from the top, when we write that minus 3 down there, it's like we took that almost and put them there. So these are all gone. And now we have 5 minus 3 on the bottom. So my answer has to stay on the bottom. So be very careful about where you are putting your answer.